Hey everybody, let's check the quality of connection, the sound, the video. Can you please confirm that you can see me and you can hear me? Because it's always a question for me, I'm trying to experiment with the microphone, with, with the video software. It's always a problem. So I need your confirmation that you can see my face and you can see my code and you can hear my voice. Can you say something in the chat and confirm that? And actually, it's funny that YouTube is usually cutting off the first few minutes from the recording, and I don't know why they're doing that, so it's just happening. So it's no problem if we say something not related to programming in the beginning. So guys, can you hear me and can you see me? Please confirm in the chat. Somebody. I see there are more than 30 people there in the chat, so I need your confirmation. In the meantime, I can say that this webinar is going to be about, well, as usual, about object-oriented programming, but this time is not directly about object-oriented. It's more about in general programming, well, in Java specifically now, but I'll give you basically 8 recommendations, 8 hints relevant to how you work with the exceptions in your code and how you deal with exceptions and what are the good practices to deal with exceptions. And I will use an example for that. So can you confirm that you can hear me? Somebody say something in the chat, because I need to know that for sure before I go too far. Everything is good? Is anyone listening? So you can see the code on the screen, and this is the code we're going to work with. That's a very simple piece of Java code, just an example, and it will become larger during the next hour. So let me check maybe there's something wrong with the YouTube because I don't see anything in the chat. Now I'm going to ask you explicitly in the chat. Anyone? Answer me. I need to know you're there and you can hear me and you can see me. Let me try again. Maybe I don't see the chat. I'm going to reload this page. Yeah, okay. Okay, now it says my chat is broken. Okay, I'm back. Now I can see your messages, guys. So, okay, I'm sorry for this hassle in the beginning. Sound is not strong. Okay, let me make it louder. How about this? Can you hear it now? I just don't want it to be. Too loud because it gets too noisy. So now is it good? Is it good now? What about my sound? Should be good enough, I think. So I'm trying to. I made my microphone a bit higher, but that's probably the maximum I can use. So it's good. Yeah, great. Okay, so again, forgive me for this intro problems, and now again, this is our webinar about object-oriented programming. We will be as usual, we discuss object-oriented ideas, practices and principles of object-oriented programming. But this time, it's not going to be directly about object-oriented programming, more about the principles and good practices for exception handling. And I'm going to give you 8 recommendations, 8 things which I believe are important for anyone who is working with exceptions in Java specifically, and any other languages as well. So I will use Java because this language is the closest for me. I understand it better than other languages. So I will give you, like I said, 8 suggestions, 8 ideas, and we will go from the simple one to the most advanced one. And probably you're going to learn something that will take about, I don't know, definitely less than an hour. So let's start with the first one. So first of all, that's the example of the code. So we have like very simple primitive class foo, which does what it does with the one method. You see what it does. It counts files in a directory, and that's the directory as a parameter, and then it returns how many files are out there. And in order to calculate that, we have this static method used from JDK. We just do walk, and then we count it, and then we, count. It doesn't matter. What matters is that it's red, so because it throws a checked exception. So the first step we need to do with this something, because the code doesn't compile. So the first we need to there are 2 options basically. The IDE suggests 2 options, and I suggest you to do the second option. And if you do it like this, then some people, and actually I think I changed that in IDE, because the standard way would be something like this. And this is called whatever. Let's go this way. So this is all right. I don't know, we can go this way. So this is very standard way. You can find that in books, actually. You can find it in many places. And this approach is called exception swallowing, so-called. So we see the problem, something happened with the input-output, and then we just swallow this exception, meaning that we print it and we return something like 0. Okay, there are no files in this directory because there was an exception. So it may be a pretty reasonable answer in some cases, but in some cases it may not. For example, the directory is absent, or maybe there is no access to the file system, or maybe there are many other things which can happen, but we swallow the exception, so we ignore it basically. So we completely ignore this failure situation. We log something, which is good because some people do it like this, and that's a bad practice. So we shouldn't do that. We instead should something throw back. So this is the checked exception. So we may want to throw something like this, like throw runtime exception. That's a better approach. That's the right approach, actually. Instead of ignoring the exception, you throw something back. That's my first recommendation, which is probably everybody knows already. You don't need me for saying that. My second recommendation, so maybe let's try to record it somewhere here. Well, we don't have too much space on the screen. But anyway, so remember, the first one, always do something with the exception and throw something back. Never ignore it. So if you get an exception, it means you have to throw an exception. There are no other options. You have an exception, you throw it. The next suggestion is that I still recommend, and probably you know about this from my blog, that I recommend to do checked exceptions. So I would say, if you can, then of course for the checked exception you will have to do something like this. So I suggest you to always, when you can, try to organize your code the way that all the methods, especially in Java, actually probably this is one of the few languages in the world, Java, which actually have this so-called checked exception. So I still recommend to use this feature, even though there are many contradictions, there are many questions about that, and many people say it's wrong, but I still believe that checked exception is a good idea. So you declare what you have here. So you basically say, like, you throw something which is so-called checked, and then you of course explain it. Then of course you explain it here, and you say that I throw this exception when I can't count files. So that will be a pretty good, message for people that they have to do something with the exception. Because if you don't do this, if you throw an unchecked exception, then your method signature will look like this, and people who use it will never expect any troubles from there, and they will design their code without this information, which may be important, which may give them some hints and some suggestions, something which may help them. That's my second suggestion. So try to use checked exception. Suggestion number 3 is that it is important when you throw an exception, and actually when we move from one suggestion to another, in the end we're going to have the right code, the good code, because now the code is not perfect. You see we have red here, so don't take it for the final recommendation. So definitely the code you see on the screen is not perfect, so we still need to improve it. So the next improvement is basically to do it like this. So we want to say, and actually I suggest to rename it. So we want to say, you know why it's red, right? Why do you think it says it's red? Okay, there's a hint. So this is a better way. So we need to do so-called exception chaining. This is how we deliver the information to the user, to the place which called us. We tell them what was the cause. This one is called cause. If you click at this, you probably will gonna see the cause, you see? That's the name of the argument. So they call it cause. So what was the original problem which caused that exception? If you don't do it like this, if you throw it like this, first of all, you see it actually complains. It compiles, the code compiles, but even IntelliJ, the IDE complains. So we all know that exception chaining is a good practice. So you never forget, you never swallow the cause of the exception. So you never throw it away. You need to embed it into the exception which you throw back. And actually Java is a very convenient language for that, because in some other languages which I met, this exception chaining, it's difficult, much more difficult to make comparing to Java. So Java is very good. It's very good for exception chaining. So you do exception chaining every time. That's my recommendation number 3. Number 4 is when you hold on. Yeah. Number 4 is this. Even if you don't need to, I would recommend to do this throwing of an exception here. Maybe this recommendation can go after the 2 exceptions I'm going to give you now. So let's do 2 recommendations before we go there. So the next recommendation is that instead of using exception, of course, exception is not a good idea to use. So maybe I don't even need to tell you about this. Like IntelliJ will complain about this as well. So you don't use standard exceptions. Of course, you don't use exception, this default class. That's for sure. And I suggest not to use even the standard exceptions like this, like IO exception, for example, which you may use here and say, look, for example, like this, even though it doesn't make any sense here because you catch IO exception and you throw it again. But hold on and wait and stay with me for a minute. So I suggest to use custom exceptions. So here, let's say you have the class foo, you design, you make the public static final class my exception or something like this, and then you make it extends exception, and then you make it public my exception with the parameter, just like they do in other exceptions, and then you do super. That's all you need to do. That's your exception, and then you throw it here. Now we're good. So this is my recommendation number 4. So you always try to, when you can, and if you design your library, when you design something good, not just a temporary piece of code, but a good piece of code, then it's a good practice that every class you design, every class, pay attention, throws exceptions which are custom for this specific class. So when you ship the class and the class has a collection of these these static classes inside the exceptions. That's just a good, for me, it's my recommendation. For me, it's an indicator of a good design. For me, it's easier to understand what the person wanted here and what's going on with this information. This is very specific information, so I understand that people are not just throwing whatever, but they actually mean something by that. And of course, in your specific situation, you don't need to call it my exception. You call it can't count files exception. That would be the right name. So you say it can't count files exception. That would be the right name for this exception. It complains. You probably know why. So it wants the class to be in front of it. So this is kind of an information you give to your customer. You just tell your customer that in case I can't count, then this is my exception. In case something else happens, then there should be something else. And now we're getting to my next recommendation, which I wanted to tell you before, is that even if you, that's recommendation number 5, is that even if you don't need to catch an exception like here, because here we had to do it. Well, like we can't compile the code like this, remember, because it was complaining about this method. So we had to do this try catch and so on. But sometimes we don't even need to do that. For example, let's go to this walk class and see what happens in there. You see, they say that they throw security exceptions sometimes. Maybe it's not a good example because the security exception, it goes from many places in Java, but still, I would suggest to do something like this. Maybe in this case, it's not really a perfect example. You may say that the security exception is not something that you really want to catch, but I would suggest to always think about what else you can catch, what else can happen there, so that you deliver the information to your user in the most extensive way. And here you say counting security. I don't know. I'm improvising. Security issue on counting, something like that. So you catch the exception which is default, and then you create your own exception class and throw it out from there. And of course, you will have to list it there and say blah blah blah, something like that, which is a questionable recommendation, because I suggest to have one checked exception here, and if possible to somehow to join them all together, so there would be one mistake, one mistake always. So maybe that would be a better design like this. Yeah, that's what I would suggest to do. And why? You may ask why. What is the point of catching runtime exception? Because this is a runtime exception. This is unchecked exception. So meaning that we may easily ignore it, and that code will compile as well. But I suggest not to do that. My recommendation is to list, as many as possible exceptions which you know about, which you care about. Why? And now we're getting to the next recommendation, number, if you're counting, it's probably number 6. So I would say that just throwing it like this is not enough, because you basically do not help your user who is catching this stuff. You're not delivering the context of your problem, the context of what happens there. So they will not understand. They will just see basically exactly what was here. They will see it here. So if this IO exception will say file not found, and this is how JDK actually is doing it, which is why I don't like this. Well, I think this design is not really good in JDK. Maybe these people who designed JDK didn't have enough time or didn't pay enough attention. But usually their exceptions are quite blind. They're quite primitive. And the messages which go with them are very simple or basically don't exist at all. So I suggest to do it this way. I suggest to say something like, we failed to count files in the directory. Yeah, and in order to do that, of course, I would, you would do another constructor here just in case, or maybe you can use the same constructor. Okay, this is one case. Oh, yeah, the other way around. Okay, funny. So we do it the other way around, even though it looks to me wrong. I would do it this way. I would say the cause goes first and the message goes next, but they want it this way. Anyway, let's do it in a consistent Java way. So we put it first, then we put it next. And that's a much better way to throw an exception. So make it a rule for you. So you never just throw an exception just with X here and that's it. That's a bad style. Because in this case, you don't add any information for the user. So they don't know those people, those classes, those layers of your software which will catch your exception on the highest level. They will not understand what's going on because this information, the information on this IO exception or security exception, will not have too much details. So especially in the security exception. And very often people at the highest level of your application, for example, it's a web system, then they catch exceptions from many different places in the application, and they not always, they print the stack trace on the logs. Sometimes I saw large applications where a lot of mistakes, a lot of exceptions are coming from different places in the app, like hundreds of them, like every minute or every second. And it's impossible to print the stack trace for all the exceptions because the log will be huge and difficult to read. So sometimes people just print the message of the exception. So all you see in the logs is just error and then the message, the error and the message, no stack trace. And in this case, if the security exception is coming from there, then everything you're going to see there, it will be like security violation. What kind of security violation? When it happened? Why it happened? Nobody going to know. So it's much better if they will see this. Like we failed to found files in the directory. That will be a much richer information for them, more information for them. So try to help them, try to help your users. And now we're coming to the recommendation number 7. Of course, this information is not sufficient enough, as you can see. This is a very primitive piece of information. We failed to count files in which directory. So I would suggest to do it like this. Always do it like this. So as much as you can, as much information you can, to do we failed to count in something like that in the directory. So that will be even better, better attitude to people who use your software. Not just throw them an exception, not just throw them an exception with the text, but explain in your text what's going on, like what exactly failed. And as much information you can give here, the more information you can give here, the better. Maybe you can say something, I don't know, maybe in your class foo you can say like, maybe you have some attributes, like, I don't know, private int ID or something. In this case, you say, we failed to count files as ID. Our ID is, that would be even better. So the more information you can give, the more context, this is called context, the more you help your customers, the more you give them, what do you call it, the hints, so they can get back to your code, find your code, and fix your code. And for yourself as well. Maybe you will be the one who is reading the logs, and you will be getting this information in order to fix the problem. You see now our code is becoming much better. So that code. This code looks actually good for me, and I think this is a pretty good code. And now the final recommendation. So still the code is not perfect. Still we have issues, and this issue is quite important, and this is the final touch, the final recommendation. So I would suggest to pay attention to the data you put there, and think about security. Not only security, but basically the way you print this data. And if you say it like this, and somebody for some reason, for some I don't know, maybe an ejection, maybe something for a purpose, or maybe something by mistake, here the information will be provided with some sensitive data. Then you're going to basically print in the log file maybe some sensitive information about the user, or maybe not sensitive information. Maybe there will be a file which is created, which is constructed with a very large piece of text, inside the constructor. So it's not really a file pass. It's not really a location of the file anymore. But because of the mistake, there will be like a large piece of text, maybe with security codes, maybe with something, and you're gonna basically print it on the log, and nobody gonna be happy to see that in the log, and you will suffer for that because you made it. So I suggest to do something like that. Something like, for example, well, this is the primitive way. Let's do toString. This is very primitive way, and then you do replace all, and you do, let's say, anything which is, it's a regular expression, anything that is not a letter or this or space, then we just change it to dot. So in this case, you basically gonna, and still it's not enough, because in this case you're gonna remove all the symbols, so the text will be in one line, so it'll be like new lines will be removed, everything will be in one line, but still it may contain the password or something. So I would suggest to do, if it's very, very super secure place, then maybe what I do sometimes is you can do, for example, replace all, and then you take the beginning, the end, and then you take, for example, the first, I don't know, the first maybe 10 symbols, and then you take something, and then you take the last. I'm not really an expert in regular expressions, but still. And then you do, and then like this. So it's gonna basically take the first 10 elements from the beginning of the string, and then it's gonna take the last 10 elements from the beginning of the string, and I guess it will, replace everything else which stays between them with the double dot. Also not perfect maybe. So maybe after this you can also do something. I don't know, some scrambling. It's called data scrambling basically, if I'm not mistaken. So this operation is called data scrambling. Like you scramble the eggs, so now we're scrambling the data. So we're making the data completely unreadable for somebody who is trying to get the real information from there, but it's still good for those who care about the context. So even if you do this with the name of the file, it's still going to be quite easy to understand. Maybe you can use the slash in here as well. So it will be quite easy to understand for the reader, for yourself, like which file we're talking about when you look at the logs. But if there will be some secret data, and there will be some occasionally, accidentally, information appear there which is too large for a file name, and like I explained, like some binary data for some reason, then still the log will be pretty clean. So nobody gonna complain about that you drop too much data in the log. So try to find a compromise. So try to scramble the data as much as you can. Maybe you can even, I don't know, if it's a password, maybe you somehow can encrypt the data somehow. Maybe you can do some here you can do some encryption of the data, like, I don't know, maybe like this. Yeah, you can make another class encrypt, which will take all the data and scramble it. Sometimes it's also convenient to use the class from Apache library, which is called string escape utils, if I remember it correctly. And there you can do escape or something like HTML or something like that. So that's pretty convenient set of utils which will help you to take your code and make it look nicer for logs. So you remember that every time you log an exception, there is a chance that this log will be seen by many people. So you give the context information, but you scramble it enough so that it doesn't hit you back when some security guys will show up and say that, and start asking questions, who was the developer and who did it. So if you, I don't know about this encrypt, I don't really do encryption. Usually I'm not really that much, about security, but this looks like a pretty good code for me. If you compare this code with what we started with, then this one is definitely better. So 8 recommendations. Number 1, I can go through them again and then we go to your questions. Number 1, you never swallow exceptions. Number 2, you always use checked exceptions, and I suggest to use one checked exception for each method, not more than one, just one checked exception. Number 3 is that you make your own exceptions. Or maybe this is together. Number 2 is you make them checked and you make your own exceptions. Number 3, no, sorry, let's start from scratch. Let me reiterate. So first of all, you never swallow the exception. Second, you use checked exceptions. Always one exception per method. Number 3, you always chain exceptions. Number 4, you always try to catch whatever you can catch and rethrow it. So don't rely on the default exceptions which are thrown there, and don't let them just quietly go through you and go to the higher level. You better think about how you can catch them and make them, convert them to your own exceptions, because this way you can add context. If you just let the security exception go up, you are losing the opportunity to jump into this process and add your context and let this context flow up. That's number 4. Number 5 is that you use your custom exceptions. Number 6 is that you always try to add some context, some text, so not only the chaining, but also with the text. Number 7 is that you put some extra data into the context. The more data you put, the better. And number 8 is that you scramble the data. So don't leave the data as is. Try to be more careful with it. So that's probably it. That's all I wanted to say. And now I'm ready for your questions. We have about 90 people watching us now. That's great. So let me scroll up and see what are the questions you have. First, it's not a question, basically a recommendation. Throw or not an exception depends on the layer where the exception was happening. Libraries like low level should throw. Use cases high level shouldn't, just log, for example. Well, definitely we understand that we throw exceptions, of course, on all the possible layers, and then at the highest level, we catch the exception, then we do something with the exception. I said it many times that the ideal design is that when you throw your exceptions in many places in your application, everywhere, and you catch it only once. So only one place where you catch your exception. That's the ideal design. It's difficult to get there. Well, only probably very small applications can achieve it. I'm trying to achieve it every time, but not always it's possible. But that's the ideal design. One place is where you catch the exception finally. Catch and not throw again. So where you actually swallow. So when you catch it and you do something with it. In all other places, you catch and throw again. You catch and rethrow. So Marcus is right. That's the proper comment. And then another comment is the message almost duplicates the exception's name. Yeah, of course, that would be silly to use exception, the text, which is identical to the exception name. So exception name should be short, and then the text should be longer. So be creative, of course, don't just repeat it. Another comment, this one I didn't understand. Another one, exception is also raised when the user's input or usage of the method is not valid. And you perfectly know the reason why the input is invalid, but you can't afford returning a false or something. Well, that's a separate question outside of this webinar, when to throw an exception, because I was trying to show you what to do with exceptions, how to throw exceptions and when to throw them. I could give one generic suggestion. Just do it as frequently as you can. The more you throw exceptions, the more places in your application actually throws exception, or in your library, the better for everybody. So throw as much as you can. That should be the habit. Like anything goes wrong, anytime you don't like any parameters, anything you don't feel comfortable with, you immediately throw an exception. So don't hesitate, don't think twice. Like, do you need to throw, or you need to think more about it? No. So never try to save the situation. Never try to do something to let your code survive and try to improve the situation, even though you understand that the parameters which are coming to you, for example, or the situation is bad. So you just throw an exception. Don't solve problems. Let other layers know about problems and let them solve. So escalate the problem to higher level. That's a generic recommendation. And it's called fail fast. So you can read about that. It's a fail fast philosophy of software development. We had other webinars about that, how important it is. Next question. Now there are people talking to each other. Now Marcus again. This code to throw a new exception looks so complex that it's better to not continue throwing. It shows that this layer could be high level as the message looks like for user. No, I don't think this code is complex. I don't find it complex. To me, this code looks pretty good. I mean, yeah, you may say that, look, the real code is this, and the code that does, handling of the error is this. But I believe that this is how it should be. I think that the majority of our code should be dedicated to exception handling, to dealing with error situations. Like the optimistic scenario is like a few lines, and then few, I don't know, a few dozen of lines go for dealing with problems, dealing with situations which are problematic. So this code doesn't look wrong to me. Actually, this code looks right to me. I like to read the code like this because I can see that people really care about their users. So they don't just let other people deal with the problems, but they care, they look, they understand that they need to catch a few situations. Now they spend some time to prepare the properly formatted details about the context. So this code is really, done with care. So people who write that kind of code, I can easily say that they care about their users. When I see the code like this, then I know that the person who wrote this code has completely no willing and no desire to help its users. It's like completely careless coding. That's a code of an immature programmer, or maybe a mature one, but who doesn't care about nobody. So this code is perfect. I mean, this is how your code should look. That's for sure. So Marcus, that's my answer to you. Next one. Is it a good idea, Vladimir is asking, is it a good idea to have a complex hierarchy of custom exceptions using subclasses? For this example, we could have something like class. Yes, that's a good question, definitely. I'm definitely in favor of hierarchies of checked exceptions, that's for sure. So you need to have a big tree of exceptions which are actually delivering information to us, your users, the information about your error handling strategy. So by building this tree of exceptions, you're actually telling us, your users, like how you classify problems and how you want us to classify problems. So when I open the library, and in this library I see that there's only one type of exceptions, that kind of tells me that that library doesn't really care much about us users. So again, the more detailed is your tree of exceptions, the better. Next one, Denise is asking, I like checked exceptions, but Kotlin doesn't have them. How can I get around this? Well, as you know, Kotlin is a great language for, I think, for more primitive, less mature programmers. Not say primitive, but less mature programmers. So Kotlin was designed to simplify life of people who want their life to be simplified in a simple way. And that's how we got Kotlin. So I mean, Java is definitely, Java is not perfect. I don't like Java as a language. I think there are many issues in the language, but it is the language where you can actually design things right. You can easily design it wrong, but you can design right. Just as C++ also, you can easily ruin things. You can easily ruin everything. But if you know how to use C++, you can do things very well. So Kotlin, I don't have any suggestions for you what to do with Kotlin. Use runtime exceptions. Just use runtime exceptions. Actually, runtime exceptions, they can be caught as well. You can deal with runtime exceptions exactly the same way as with checked exceptions, but your methods will not have the declaration, their signatures will not have the declaration of the exceptions they throw, but you can use JavaDoc, you can use the documentation blocks and say it there. Of course, it's not that strong because the language will not enforce anything, but that's kind of a workaround. But still use it. So still think about the hierarchy of exceptions, still use your own classes. Everything else I said today counts, everything else is relevant to Kotlin as well. The only thing is not relevant is, yeah, you cannot do checked exception. The next question, Evgeny, can you show a few examples from real project? From real project, I can try. This is the real project. I was just working today with this project. This is actually, this is my code. I was writing it today. No, that's not too much exception handling. Well, this is maybe the real example. Yeah, I took it from here. So these files walk. that was the sample I took from the real code. So that's my real code. You see? So the one I showed you before was not real, but here this one is real. So look, I'm trying to count the lines of blah, blah, blah. I'm doing something, I'm filtering, I'm trying to compile all files in the directory. And then, of course, I know that we're going to fail, so the IO exception is possible. And if it happens, then I throw Mojo failure exception because it's a Maven plugin. And if it happens, then I go the text, and I make the formatted text, and then I format the text. So I do everything, and then I provide the exception. So I do the chaining with the context. So it's exactly what I was telling you about. But look, I don't do scrambling. My bad. So I don't do scrambling. I just show everything. But in this case, I kind of rely on Maven because this is going to be a run inside Maven. It's a plugin for Maven. So I kind of trust Maven that they're not gonna send me something wrong here. So they will probably test first that this is really a directory. So I'm not going to ruin everything if I do it like this. So that's a real example of the real live code. Can I show you something else? Yeah, another one. Look. Also, I catch the exception, and then I do the same story. So I say, this is the way I format exceptions. I say illegal state exception. Okay, my bad. This is illegal state exception. Not a good idea. It would be better to design their own exception. But again, it's a Maven plugin, so I'm not designing a library. So basically, there are no users for this. So the only user is Maven, so I don't care. And then I compile, I create the text. So I format the code, can compile something into something, then I provide the parameters, and then I chain the exceptions. So that's pretty real code. If you wanted to see it, then this is my code. Next one, you shouldn't, next one, Dennis, if you want to convert to your own specific exception, as many exceptions as possible, you should catch exception. Well, yeah, it's a good comment actually. I think that catching like here exception, maybe it's not a bad idea, but the compiler will complain. I mean, not the compiler, but IDE will complain about this. As you can see now, it's complaining. Well, this is one about this. So yeah, you can do it like that. Maybe this is not, like in general, not a bad idea, but IntelliJ will complain for sure that you catch all exceptions. It's too broad. And you may have the static analyzers. All static analyzers will complain about that. And of course, we know that we use static analyzers like checkstyle, PMD, at least for Java. So they all gonna complain. Why it's wrong? Let me think about this. Why we don't want to catch everything? Maybe there's also a demonstration of us being careless. So we don't really care about exactly what is there, so we didn't check exactly what kind of exceptions are there, and it kind of sends a wrong message to our users, like we catch everything without paying attention to what matters. No, I mean, I think it was like kind of a joke, but no, in this case, no. Next one, probably decorating, Gonzalo is asking, probably decorating the object to put exception handling to eliminate verbose code would be another approach. Decorating the object to put exception handling. That's also possible. That's also possible. We have this in Cactus, and I'm using this library here. I can show you how. I just showed you the code, and I can show you where we're doing exactly what Gonzalo is talking about. So let's say, for example, this class, this unchecked exception, unchecked text, is basically doing only one thing. If you click it, it basically does this. It does something that you encapsulate, and then it catches all exceptions, and then it returns some default, so it basically converts it to runtime exception. But here, we don't want to do all of that, so that's why we created this. That's from the library called Cactus. It's very convenient. There are many classes like this in Cactus, where you, instead of doing try-catch, you just decorate your code, decorate your class, your object, with some specific object from Cactus, and that's it. So you basically get away from this try-catch construct. So good idea, try Cactus, try this library. Next question, Oswald. Is that a code opening a file with exception? Is that a code opening file with exception? I'm not sure in Java we actually open files. These days we more like read from files. I don't think this file opening is something from Java. It's more like C construct opening file. In Java we don't have that, to my knowledge. We don't have file handlers. We just read from file, and all operations with files are pretty, standard, pretty atomic. So it's not like C. So maybe I didn't understand the question. Next one. Sergey is asking, as we know, exception is a bit slow. So the question is how often you prefer to throw exception. Yeah, I know about this. I've heard that exceptions are slow, and basically it's slow because why the exceptions are slow? Because they need to build the stack trace. That's what makes them slow. So every time you throw an exception, the Java has to go through all calls which happened before and collect the information from them, like where they happened, in what files, what are the lines, what were the lines of code, and then put everything together in the array, and then deliver this array. So that's why it takes time, because they need to go through the history of calls, through the stack, and collect all this information. So I don't think that this is going to be a big problem for you, because I don't think your application will be full of exceptions, and if it will, then probably your design is wrong, because this is the very popular anti-pattern called they call it, let me write it for you, it's called flow control by exception. Like this. So if you do flow control by exception, that means that you, instead of doing normal forking, for example, if something is true, then you go left. If something is right, is wrong, then you go right. But instead of this, you do exceptions. For example, you check, and then if something's wrong, you throw an exception, and then you catch it, and this is your left branch of your forking. And if you don't catch it, then it's the right branch of your forking. And that's wrong. So it's completely unrecommended to do it, not because it's slow, but because it kind of breaks the logic of the code, and it kind of abuses the original purpose, the original concept of exceptions. So exceptions are for exceptional situations. They are not for branching. They are not for deciding which way to go. Exception means that the software is in trouble, and somebody who is running this software, like a user, like a human being, has to do something, and we need the intervention of that person, of that actor, of that entity, the real user. But exceptions should not be, you should not catch an exception and then do something and continue the execution of the program. Exception means you stop executing and you go to the highest level and you ask the user, hey, do something, probably it's time to stop and go for support line and call support line. So it's not going to make your code slower, because it's going to happen only once and then everything stops. So who cares how fast you do that? So I don't buy this idea of exceptions are slow. Nobody cares. We shouldn't care. A few more questions and we finish. Next one, Ilya is asking, what's the name of the IDEA the IDEA settings? Well, it's actually my custom settings, so you can download it from the blog. So it's my custom. I don't know. I configured it for many years ago, and I still use it. So it's dark, and all the colors the way I like them. So I'm staying with this configuration for, I don't know, maybe for 10 years already. If you want to download it, it's available on my blog. You just go to the blog, my blog, and types in the search line. You type settings for IDEA or settings for IntelliJ, and you're gonna find the blog post where the file is attached. You just download the file, and you can use exactly the same. It's free. Next one. As we know, exceptions. Sergey is asking, as we know, exceptions a bit slow. Okay, yeah, we answered that. Vladimir is suggesting that actually the root of exception is throwable and not exception. So if you want to catch everything, you should use throwable. Yeah, you probably know the difference between throwable and exception. So exception is something that you can't catch, and throwable is the root of this. And some exceptions are not from exception; they're from throwable. And to my knowledge, those are like system errors which you're not supposed to catch ever, because they are indicators of something really serious problems with like Java machine or memory or like input-output system. So you don't catch that. You basically let it kill the process, let it kill the application, because something is terribly wrong. So that's my understanding. So everything that is not under exception, under the class exception, that you don't touch that stuff. Okay, next question. Sorry to say that. Let's make it the final question. What worst could happen of using exception? What can happen of using an exception? Well, the worst probably. Probably the question is about the mistake. What is the worst mistake you can make if you don't use exceptions, right? I think that the worst mistake is the one we started from. If you swallow exceptions, if you catch an exception and you swallow the exception and you ignore it. So that's the most terrible, the ugliest design, the most terrible mistake. So don't do it. So never swallow exceptions. That's the mistake you don't make. Everything else is forgivable. So if you don't provide enough context, then we're gonna find a way where you do it and fix it. But if you swallow exceptions, it's difficult to find where you did that. It's difficult to understand why it's happening. It's difficult to. It's a trouble. If you do that, you're not a software developer. So that's an unforgivable mistake. Don't do that. Everything else is more like hints. So that's enough. Thanks for listening. I hope I delivered you some information. Maybe it will help you to design your software better. So I see you next time on our next webinar. It's going to happen on the first Wednesday of January. It's going to be right after New Year holidays. Every time we talk about object-oriented software, I encourage you to write good code, and I recommend you to read my books, my blog. So you know my blog probably, you know I publish a few books about object-oriented programming, so I think you may want to read them. And of course, stay subscribed to my YouTube channel. I have some videos coming every few days. And thanks for coming today. Bye-bye. It was nice being with you guys.